Welcome back. In this chapter, let's learn about constructors and destructors in C++. This is what we will be learning. What is a constructor? The constructor is a special function, or method, of any class, which automatically executes when an object of the class is created. Hence, a constructor is the first function that automatically executes when an object is created. Programmers edit a constructor function to initialize specific values, allocate dynamic memory, etc. A constructor will have same name as that of the class, and has no return value, not even void. Constructors cannot be called explicitly as if they were regular member functions. They are only executed when a new object of that class is created. Syntax to declare a constructor is class name argument list. For example, motion function, with incoming parameters float, and int, where motion is the class. The syntax to define a constructor is class name, scope resolution operator, class name function with argument list, followed by body of the constructor function. What is a destructor? A destructor is the special function, or method of a class, which automatically executes when an object of the class is destroyed. The destructor has same name as that of the class, and has to be preceded with a tilde sign, and has no return value. An object is destroyed when, number 1. Its scope of existence has finished. For example, at the end of a program, or at the end of a function in which the object was declared. And number 2. When it is a dynamically assigned object, and is released using the operator delete. The destructor can be used to free unwanted memory space that's no longer needed in a program. We can edit the destructor method to deallocate memory occupied by an object. This is an example of the destructor function is declared. Tilde, motion function, where motion is the class. This destructor function can then be defined with required functionalities. Overloading the constructor. In the chapter on functions we learned function overloading, where a function was redefined multiple times with different parameters and different return types so that it could be reused to perform different tasks. The constructor is a function. Hence, the constructor can be overloaded with more than one task, by redefining the constructor multiple times and passing it with different parameters. This is constructor overloading. Remember that for overloaded functions, the compiler will call that function, whose parameters match the argument list used in a function call. Similarly, in the case of constructor overloading, the exact function that is executed is the one that matches the arguments passed during object declaration. Let's now write a program and get a better idea of how constructors and destructors work. The requirement is to find the elements of motion based on the general formula, distance equals speed multiplied by time. Use the features of constructor, destructor, and constructor overloading. So here is the program code, and this is the class named motion. We have declared two double-type variables, distance and time. Then we have the public access declaration. Next is the motion function, which is the default constructor function of this class named motion. It's defined outside the class here. This function prompts the user to enter the values for distance traveled and time taken. It then computes the speed of travel and prints it. On line 8 we have our first, overloaded, constructor function. It will be passed with two parameters, an integer, and a double value. It is also defined outside the class here. This function calculates the distance traveled, by working with values of time and speed, that are passed into this function from the main program. Next in the class is declared another overloaded constructor function, which carries two double parameters. It's defined here. This function calculates the time taken, by working on speed, and distance traveled, that are passed into this function from the main program. Finally, the class has destructor function, preceded by the tilde symbol. It is also defined outside the class. It's here. This function demonstrates how memory allocated for variables declared in the class are deleted or deallocated. Program control now enters the main function. On line 39, we instantiate an object named speed of the class motion. So the object named speed is created. When an object is created, its constructor function automatically gets executed. Here, since speed is an object of the class motion, the motion function is executed automatically. This function prompts the user to enter a value for distance traveled in kilometers. I enter 120. It's stored in the variable distance. The function then prompts for time taken in hours. I enter 3. It's stored in the variable time. In the constructor function, on line 16, the program calculates speed of travel and has the value printed onto output screen. In program code, the control now shifts to line 40, where a new object, time, of the class motion, is instantiated. It is passed with two parameter values, 62.5 and 205.5. Both these are decimal values. Hence, the overloaded constructor function with two double values as parameters will be invoked. The two parameter values, 62.5 and 205.5, are copied to the overloaded function and assigned to the carrier variables, AA and B. Speed and distance are printed. Time taken is computed and printed on output screen. In program code, the control next shifts to line 41, where another new object, distance, of the class motion, is instantiated. It is passed with two parameter values, 3 and 58.5. First one is an integer, and the other is a decimal. Hence, the overloaded constructor function with an integer and a double value as parameters will be invoked. The two parameter values, 3 and 58.5, are copied to the overloaded function and assigned to carrier variables, int a and b. Time taken and speed of travel are printed. Distance traveled is computed and then printed onto output screen. The program ends. It's here that the destructor function works. Check lines 32 to 36. We have asked to delete the memory spaces allocated for variables, distance, and time. Can you guess how many times the destructor will work? It is 3 times, because we have created 3 objects from the class, and the destructor function works for each one of the created object. I hope you enjoyed it. So what did we learn from this program? We learned to use the constructor and destructor functions. We also learned to overload the constructor function to perform different operations. We used the constructor function to either find the speed, or to find the distance traveled, or to find the time taken to travel. Default constructor. C++ compiler always creates a default constructor if you do not specify your own, and provides 3 special member functions in all that are implicitly declared if you do not declare your own. These 3 are the copy constructor, copy assignment operator, and default destructor. Copy constructor executes when a new object is created from already existing object. As copy of existing object. Assignment operator creates a copy of values from existing object and assigns it to another initialized object. The copy constructor and copy assignment operator copies all the data contained in another object, or the constructor explicitly declared, to the data members of current object, that is, the default constructor. For a Class C example, the copy constructor implicitly declared is similar to C example class, containing the C example constructor function, with reference parameter, constant C example &RV. Within the function we have 3 assignments. A equals RV.A, B equals RV.B, and C equals RV.C. Note that here, RV is reference variable to the address of explicit constructor C example. Value of variable A, in RV, is assigned to variable A, in default constructor, similarly B and C are assigned. So the following object declarations are correct. C example EX function, with 2 and 3 as parameters. And then, C example EX2 function, with EX as parameter. So here, EX2 is the copy constructor that carries data copied from the object EX, which was initialized in the last line. We now conclude the chapter on constructors and destructors in C++. In the next chapter, we will take a quick look at friend functions and operator overloading in class and objects. Until then, take care.